Hey everyone, we're now doing section 2.4, measures of variation in our textbook. And variation is really a measurement that just what separates something else from something else. Why are they different? What kind of numbers can we use to describe this difference? So there are two really easy ones we want to talk about right away. The first measure of variation is the range. And the range in a given data set is just the maximum minus the minimum. And it really tells us how far apart the top two data sets are. What's a deviation? Well, a deviation is taking one element of a data set, say x, and then subtracting the mean of the data set, if it's a sample mean or the population mean, from that data point x. And then this will be equal to the deviation of x. And this just tells us how far a data point is from any other, from the center of the set of data. So I have one class where the minimum grade is 18% and the maximum grade is 78%, and the average grade in that class is about 50%. So my question to you is, what is the range? And what would the deviation be for somebody who had a grade of 70%? Okay, so find those two and then check back. Alright, so the minimum is 18, the max is 78. Therefore, the range is equal to the maximum minus the minimum, or in this case, a 60% range between the high and the low score. And the deviation of somebody who has a 70% in class is let me write deviation of 70% is equal to 70 minus 50, the mean, which is 20%. So that person's is above. Now, if I asked you to find the deviation of somebody with a 30% average in class, then that would be 30 minus 50, or a negative 20%. So negatives are allowable on deviations. Okay, let's go to the next slide and we shall talk about variance and standard deviation. So the next kind of measure of variation that we had is actually called the variance. And we have what's called a population variance and a sample variance. And if you look at these formulas, there's a little difference in notation. So I want to talk about those a little bit. The first one is the population variance. It uses the Greek letter small sigma. And you go back and look, I made it by starting here and curling around. And it's written as sigma squared. And what it's equal to is this expression on the right hand of the equality. So this symbol means sum, okay, and as you know, this is the population mean mu, and n is the population size, so it'll be a big number for most populations. Anyway, to find the population variance, what you do is you find the deviation of each point. So you take each piece of data. So you take each piece of data in the population, subtract the mean from it, and square that number. And then you add all of those up. And once you add them all up, you divide by the population size. Okay, the sample variance then, instead of using sigma squared, it uses s squared right here to represent sample variance. You still take each data value and subtract the sample mean instead of the population mean, square them, add them all up, but notice the sample mean is divided by n minus 1. This is a theoretical consideration in statistics. See you. In statistics, that is something that we don't need to worry about. We just need to know what this is. Now, in general, I am not going to ask you to use these formulas to figure out standard deviation. I'm going to expect you to do it by calculator. All right? So I am going to show you how this is done on a calculator so that you have that information available. Okay? And that will help you find the variance. Closely related to the variance, either the population or the sample, is if you take the square root of the population variance, so the square root of sigma squared, which is equal to just sigma, then that is going to be, and it's the square root of the whole formula, that's going to be equal to the population standard deviation. And in the same way, if you take the square root of s squared, that'll give you s, and that's equal to the sample standard deviation. And so what you're going to see when we do the calculator is that the calculator actually calculates standard deviation. And then I might spend a little time showing you how long this takes to do by hand, but why it's so important that we can use technology to help us calculate these things. We're just going to need to know what they mean. Now, just to finish, a standard deviation is, in reality, it's kind of an average deviation. It measures how far away on average are data from the center or the mean. I want to find a set of data and use that set of data to then find the standard deviation. So I'm grabbing a set of data from your textbook, and I'm going to enter it in my calculator, much like we have learned. You will notice that I'm just moving through and clearing data from my calculator so I can go on from there. Okay, we're going to pause this video and I'm going to enter the data in. As you can see, I now have data over on the left side, and I've entered that data in my calculator just as we have done before. So now I'm going to proceed, and I'm going to go find the standard deviation. So as always, I press the stat button, and I go calculate, and in my case, I press one variable statistics. I tell it the data is in this one, and then I press enter. And when I press enter, there's the mean, like we always thought it would be, the sample mean, 7.9. And if I want the standard deviation, where I need to look is down where it says S, X, and sigma X. And those are the numbers I'm going to use. So I'm going to take a picture and paste this into the presentation. So what you'll see on the screen is, as I've said before, are the things that we need turn out to be the S of X and the sigma of X. And so the calculator, these are the notation for the standard deviation of a sample and the standard deviation of a population. And these are the two numbers that we would need. If our original data was a population, then we would use this one. If our original data was a sample, then we would use the first one. And in general, we always use the first one because most of the time our data comes from samples. Now, therefore, my standard deviation, and I could write this on a homework, I could say my standard deviation is equal to 2.60. So I could round it off to however many decimal places I needed based on whatever the problem said. Now once I have that, then if the problem asks me for the variance, then if you'll remember, the variance is just the square of the standard deviation. So that would be 2.60 squared, which I believe is about 6.76. And this would then be called the variance. So this first assignment, you're going to really focus on finding the range, the mean, the variance, and the standard deviation. And then the next time we get together, we're going to work on how do we interpret those? What do these numbers actually mean when we look at the data? And so there's really quite a bit that we still have to do. I am going to do a little addition to this video, which you can choose to either watch or not watch, but in general, for homework and tests, I want you to use technology to find standard deviations and variances. Your textbook has an outline of this procedure I'm going to show you that'll help you find the standard deviation. And then next time we get together on this, we're going to look at standard deviations for group data or a weighted standard deviation, and we're going to look at how to interpret standard deviation. So I'm going to add a little slide to this. Well, now skip it. I'm going to skip it. I may show you in class at that point. Okay, we'll talk to you later.